So welcome all to Sangam tutorials, Gubbi online classes for mathematics, for Ncert and Cbse 10th standard classes. So I hope you are enjoying the classes, both mathematics and physics. So in today's topic we will be going with a new chapter, that is polynomials. So this chapter is a continuation chapter from your 7th standard. So in the 7th standard class, your teachers have taught you constants, variables, algebraic expressions, everything. In 8th standard syllabus also you have come across that again, along with simple problems of identifying the types of algebraic expressions, like terms, unlike terms, simplifying them, adding, subtracting, everything you have done on it. So in 9th standard class you have come across the advanced version of that is algebraic expression, that is polynomials. So in that chapter you are going with the types of polynomials, identification of polynomials, how to differentiate a polynomial from a algebraic expression, how an algebraic expression becomes a polynomial, and you have come across a very important topic that all polynomials are algebraic expressions, but all algebraic expressions are not polynomials. So these things what you have learned in your previous classes, that is 8th and 9th. So in this session, so I will be recapitulating the things what you have already learned, and in from the next session I will be entering into your 10th standard polynomials, because it's very important. Fundamentals are very important for this chapter. So let us go with the basics required for learning polynomials in your 10th standard class. Okay. So usually the most basic thing what we come across in polynomials is constants. I hope you have heard this word, constants. So constant means the value which do not change, the value which remains fixed is called a constant. My height is not constant, my age is not constant, but okay, my height is constant. Your height is not constant, but my age is not constant. So which is fixed, that's called a constant. For example, when we come with numbers, we have some 3, 4, 6, 7, 8, 3 by 2, 7 by 6. All these numbers are called as constants because they do not change their values. So in the sense, what is a constant? 2 by 3, 7, 6 by 7, minus 3, 2 by 9, 11 by 13, and 200. So these are all constants. They have a fixed value. What are constants means? Right? They have a fixed value. The value do not change. Right? So the value which whose term, in the sense the constant's value will be, there will be a fixed value, they won't change. We come for variables. So what are variables here? So variables do not have a fixed value, they assign the value what we give to it. They are called as variables. Variables means it changes continuously. My age is not a constant, it's a variable. It changes every day, every second it changes. Right? The height of a plant changes. Right? The age of some animal changes every day. That's a variable. So here variables are usually represented by symbols, that is used as an English alphabet: Y, A, Z, B, P, M, N. So these are all called the variables. So x can take any value you give. If x is equal to 1, x is 1. If x is equal to 2, then x becomes 2. It can be given any value. But here any value cannot be given to this because they have the fixed value. So what is a variable? A variable is a term which do not have a fixed value. They assign the value what we give to them. They are called as variables. So for example, tell me how much money I have in my pocket. You cannot tell them. You can go on guessing. Sir, you may have X rupees in your pocket. You may have Y rupees in your pocket. You may have, sir, Z rupees in your pocket, because here X, Y and Z can take any values. So For guessing a constant value which we do not know, we use variables. So what are variables? They are the terms which do not have a fixed value, and then take the value what we assign to them. So here a note is there. Combination of constant and variable. Combination of constant and a variable is always, I hope you can guess the answer here. Combination of a constant and a variable is always dash. So is that a constant or a variable? So it's variable. Okay. So how it is? For example, 3 and x. 3 is a constant, x is a variable. They have combined together like this. That is 3 into x. They have combined. They are combined by the multiplication sign. 3 into x is 3x. So 3 is a constant, x is a variable. So what is 3x? Is that constant or a variable? So here 3x is a variable. So why it is a variable? Because when you put x is equal to 1, 3 1s are, it becomes 3. When you put x is equal to 2, 3 2s are, it becomes 6. When you put x is equal to 3, 3 3s are, it becomes 9. When you put x is equal to 10, it becomes 3 10s are 30. So therefore, the combination of a constant and a variable is a variable. So when they are separated, that is when they are combined by a multiplication sign. For example, 3 plus x is there. So it's also a combination of a constant and a variable. So what is this 3 plus x? Is that a constant or a variable? So here, no, it's a variable, because when you give values to x, if x is equal to 1, 3 plus 1 becomes 4. If x is equal to 2, then 3 plus 2 becomes 5. If x is equal to 10, then 10 plus 3 becomes 30. So the value of 3 plus x goes on changing when you give values to x. Therefore, 3 plus x is also a variable. Right. Next we go with another one. 9 minus y. So is this a constant or a variable? So here 9 is a constant, y is a variable. What is 9 minus y? 9 minus y is also a variable, because when you give value to y is equal to 1, 9 minus 1 is 8. If you give value y is equal to minus 2, that becomes minus into minus 2, that is 9 plus 2, that becomes 11. So here you can see that when you go on giving values to y, the value of 9 minus y goes on continuously changing according to the value of y. So therefore 9 minus y is also a variable. For example, 12 by x. Right? So 12 by x, when you divide 12 by x, we get some quotient here. So 12 is a constant, x is a variable. So what is 12 by x? 12 by x is also a variable, because when you give x is equal to 1, that becomes 12 by 1, which is equal to 12. When you give x is equal to 2, 2 1s are 2, 6 times it goes. So the value of 12 by x is 6. So therefore, as the value of x changes, 12 by x value also goes on changing continuously. So therefore, a combination of a constant and a variable, constant and a variable, constant and a variable, constant and a variable is always a variable. So you should remember this. It's very important. Okay. We'll go with another one. This is also very important. Combination of two or more variables. Two or more variables is a variable and also constant. Combination of two or more variables is a variable at times, and at times it can also be a constant. How it comes? For example, we will go with example 1. So 3x plus 2y. So it's a variable. This is a variable. So you give values to x and y. Give x is equal to 1, 3 1s are 3, y is equal to 2, plus 2 2s are 4, 3 plus 4 is 7. Give value again, 3 1s are 3, plus 2 1s are 2, 3 plus 2 is 5. So when you go on giving values to this, that is to the variables, the values goes on continuously changing. So you will be getting different types of values. Okay, keep this in your mind. So now we will come with the root thing. Combination of two or more variables is given. So for example, x plus y plus 2x minus 3y, something is there. So here x plus 2x is 3x, y minus 3y is minus 2y. So here these are the two very like terms, we know that, and these are the two like terms. When you combine these two like terms or you simplify these two like terms, you get the answer as a variable again. So the combination of variables is a variable again. Sometimes it happens x plus y minus x minus y, or you can take it like this, minus of x plus y. When you take this, so x plus y minus x minus y becomes minus y plus y cancels, minus x plus x cancels, so answer becomes 0 here. 0 is a constant. So a combination of variables is a variable, and a combination of variables sometimes it will be a constant also. In your previous classes when you were solving problems on simplification of algebraic expressions, I hope you have come across some answers at the end as 0. I hope you have done many problems on it. So that is the thing here. A combination of two or more variables is at times a variable, and at times it is also a constant. So this is the example for the combination of two variables which gives a variable, and this is the example for the combination of two variables which gives a constant. Okay, so we will go with the next concept. Okay, let us go with the very basic important terminology, that is term. Right. So what is a term? 3 is a term. In algebra, when we write a constant, that constant is also called a term. Okay. Sir, minus 10. So minus 10 is also a term. Sir, yx is also a term. Y is also a term. What is xy? Xy is also a term. Next, 3xy. What is this? This is also a term. So these are all called terms in the algebraic expression. So here 3 is called a constant. Constant is also a term. X is called the variable. Variable is also called the term. This is a combination of two variables, but which are separated by, that is, multiplication sign. And in the sense they are combined by x into y. They have come across xy. Therefore, it is a term. 3xy is also a term here. So these are called terms in the algebraic expression. So here, okay, we'll continue. xy is a term. It's called a term because it's a combination of a constant and two variables. That's called a term. So here 3 is called the numerical coefficient of x and y. So in the sense, the coefficient of 3 is x and y, the coefficient of x is 3y, the coefficient of y is 3x, and the coefficient of 3 is xy. So this is how we can go. For example, I will write once again, the coefficient of 3 is xy, coefficient of x is 3y, coefficient of y is 3x, right, and coefficient of 3x is y, coefficient of xy is 3, coefficient of 3y is x. So in different ways you can go with this. So particularly when we go, for example, minus 21x square. So in this, the numerical coefficient of x square is minus 21 and the literal coefficient of minus 21 is x square. So this is how it comes. The numerical coefficient of x square is minus 21 and the literal coefficient of minus 21 is x square. For example, I just write x. So what is the numerical coefficient of x here? It is understood that it is having 1 here, 1 as the coefficient. The numerical coefficient of x is 1. For example, minus y I write. What is the numerical coefficient of y means? It is minus 1. In arithmetic progressions, we were writing the value of some algebraic expressions using this. Okay, minus 3x square yz. So in this, the numerical coefficient of x square yz is minus 3 and the literal coefficient of minus 3 is x square yz. Along with this, the coefficient of x square is minus 3x, yz. The coefficient of z is minus 3x square y. The coefficient of y is minus 3x square z. The coefficient of minus 3, that is literal coefficient, is x square y z. So this is how we read a term. Okay, let us go with the next concept, next basic thing. So next is very important, we will get into an algebraic expression. So in an algebraic expression, it's a combination of two or more algebraic terms. It's a combination of two or more algebraic terms which are connected by addition sign, subtraction signs, subtraction and addition signs, and along with multiplication and division signs. Along with. I will give you examples. Right. Algebraic expressions. Right. 3x square plus x plus 5. So this is an algebraic expression. So in this algebraic expression, there are three terms. So this is the first term, this is the second term, and this is the third term. So therefore, there are three terms in this algebraic expression. So here, this and this terms are connected by plus sign, and this term are connected by plus sign. So therefore, it's an algebraic expression having three terms. Right. We'll go with another example. 9x square minus 6x plus 10. So it's again an algebraic expression because 9x square is a term, 6x, that is minus 6x is a term, and 10 is a term. So these three terms, among these three terms, these two are connected by minus sign and these two are connected by plus sign. Next, we'll go with another example. 9x by 5 plus 4x square plus 2. So this is again an algebraic expression. Okay, we'll take some minus sign here. So here 9x is divided by 5, right? When 5 divides 9x, the quotient what we get here can be written here. So that becomes a single term. So when you divide a term by another term, then the entirely it is considered to be a single term itself. So here 9x is different term, 5 is different term. We should not consider like that. When a term is divided by another term, whether it is a constant or a variable, that doesn't matter. So when one of the term is divided by another term, the entire quotient is considered as a single term, right? So here also 4 into x square is there, 4 is there, x square is there. These are not two different terms. These two terms taken together is called a single term, minus 2. So these two terms are connected by plus sign and these two terms are connected by minus sign. These two terms are connected by division sign, but still these two terms are considered to be the single term. So no confusion, I hope no confusion is there. Okay, so this is an algebraic expression. Okay, x minus y is an algebraic expression. X is a variable, y is a variable. They are connected by minus sign. The coefficient of x is 1, coefficient of y is here is 1. It is understood as I told you earlier. So this is an example for an algebraic expression. Okay, 6x square by some 7. 6x square by 7 is also an algebraic expression because it's a single term. Taken together, it's a single term because 6x square is not different, 7 is not different. When the term gets divided by another term, then we have to consider the entire term as a single term here. So this is an algebraic expression, right? Then we go with another one. I write just 9 and keep quiet. So this is also an algebraic expression, right? So these are all the examples for algebraic expressions. Now we'll go with the types of algebraic expression, right? So now example 1. In example 1 we'll go with monomials. So mono in the sense That's called single in the sense that it is mathematically 1. So what is a monomial? An algebraic expression having only a single term, only one term is called a monomial. For example, 3x, 9x by 4, minus 12x square, just y. So these are all the examples for monomials. Monomials means an algebraic expression having only one term is called as a monomial. So let us go with another type of algebraic expression, that is binomials. So here bi stands for 2, nomials means terms, so 2 terms. For example, x minus y is an example for a binomial because these are the 2 different terms connected by minus sign. Okay, 9x plus 21, so these are the 2 different terms connected by plus sign. 9x square by 2 is a single term, plus y, this becomes a binomial because this is a single term, this is a single term. A combination of two terms is called a binomial. X cube minus x square, it is a binomial again. So these are the examples for different types of binomial algebraic expressions. So let us go with example 3 again, trinomials. So tri stands for 3. So an algebraic expression having 3 terms is called as a trinomial. For example, 3x square minus 9x plus 1. So it's an 3 algebraic expression having 3 terms. 3x square is the first term, minus 9x is the second term, and 1 is the third term. So we should be able to differentiate this. 3x square is one of the terms. So many students, what they do is just they take 9x and call it as the second term. So from the second term you have to consider the sign also. In the sense, while writing the terms of an algebraic expression, you have to consider the sign also. So here 3x square, it is having plus sign, so that is plus 3x square. So second term is minus 9x and third term is 1. So these 3 terms are connected together by plus sign and minus sign. As they have 3 terms, therefore it is called a trinomial. So x cube plus x square plus 1. So it is a trinomial algebraic expression. And then y cube plus 3y square plus y is an example for a trinomial algebraic expression. Very simple. X plus y minus 1 is an example for a trinomial algebraic expression. So here, these are the different types of algebraic expressions. So now we will go with the next very important concept, that is polynomials. Poly means many, nomials becomes to terms. So an algebraic expression having many terms is called as a polynomial, but according to a given condition. So here I want to tell you one particular thing. All polynomials will be algebraic expressions, but all algebraic expressions cannot become polynomials. That's a very important concept you have to remember. I will show you the clear-cut difference. Right. We will go with example 1. 3x square plus 9x plus 10. So this is an algebraic expression, and together I announce that it is also a polynomial. It is an algebraic expression as well as it is a polynomial. So here, what are the conditions for a mathematical statement to become an algebraic expression? So if 2 or more algebraic terms are connected by plus or minus sign and along with division and multiplication signs, then it is called an algebraic expression. Okay, there are 3 algebraic terms here, they are connected by plus sign, therefore it is an algebraic expression. But provided, how to identify whether the given algebraic expression is a polynomial or not? That's very simple. You have to look at the variables. So here is one of the variable, that is x. Here is another variable, same type of variable. So its power is 1, its degree is 1, its exponential power is 1. Okay. So if in a given algebraic expression, look at the variables. If those variables are whole numbers or non-negative integral exponents, I will repeat. In an algebraic expression, if the powers of the variables are whole numbers or are non-negative integral exponents, then that algebraic expression becomes a polynomial. That's a very important thing. You should be able to correctly define this. So, can I call this as a polynomial now? Yes, it is an algebraic expression as well as it is a polynomial, because the power of the variable here is plus 2 and the power of the variable here is plus 1. So therefore, as they are whole numbers, this is a algebraic expression, right? Also it is a polynomial, right? We'll go with example 2. 4x square minus 3x plus 1 by x. It is an algebraic expression, no doubt in this, because 4x square is an algebraic term, minus 3x is an algebraic term, 1 by x is also an algebraic term. Therefore, it is an algebraic expression. So, it is an algebraic expression, right? Now, we have to check whether this algebraic expression is a polynomial or not. So, let us check this out. I will rewrite this. 4x square minus 3x plus 1 by x can be written as x to the power minus 1. Right? So, which are the variables? Here x square, x is the variable, x is the variable. Here also x is the variable. X has power plus 2, okay. X has power plus 1 is understood, okay. But x has power which is a negative integer. So, therefore, if any one term of an algebraic expression, will it be any type of algebraic expression, whether it is a monomial, binomial, trinomial, but any number of terms, an algebraic expression having any number of terms, let it be no problem. But among those terms in the algebraic expression, if any one particular term has its power of the variable a negative number, then it fails to become a polynomial. It is just an algebraic expression. So therefore, it is not a polynomial. So it is an algebraic expression, no doubt in that, but it is not a polynomial because the degree of the variable in this algebraic expression is a negative integer. It's not a whole number. You may tell me, sir, here it is positive, here it is a whole number, why can't you call it as a polynomial? No. All the terms, all the variables involved in that particular algebraic expression should have whole numbers as their powers, or it should be non-negative integral exponents. It's compulsory. Okay, let us go with example 3. 9 root x, I write this, plus 4x square minus 10x. Okay, minus 10. Okay. So, is this an algebraic expression? We have to check this. Yes, it is an algebraic expression. 9 root x is a term, 4x square is a term, minus 10 is a term. They are connected by plus sign, minus sign. Therefore, we can call it as an algebraic expression. Now, let us check whether it is a polynomial or not. Okay, it's an algebraic expression. So, I will rewrite this. X to the power 9 into x to the power 1 by 2. So, that is plus 4x square minus 10. So, root x is a surd actually. Root x is an irrational number. The exponential form of root x is x to the power 1 by 2. For example, I will tell you, if root 3 is there, this can be written as 3 to the power 1 by 2. If cube root of 3 is there, this can be written as 3 to the power 1 by 3. 10th root of 3 is there, this can be written as 3 to the power 1 by 10. If 11th root of 3 square is there, this can be written as 3 to the power 2 by 11. 2 comes to the numerator and 11 comes to the denominator. So, this is the surd form, this is the exponential form. Surd form, exponential form. Surd form, exponential form. Likewise, 9 into x to the power 1 by 2 is the exponential form of root x. So here x is the variable and 1 by 2 is the power we are having. But when you divide 1 by 2, you get 9x to the power 0.5 plus 4x square minus 10. So here the value x has 0.5 which is less than 1. So here it becomes an algebraic expression. It's an algebraic expression no doubt, but it is not a polynomial. So now because here the degree of the variable, as I told you, should be a whole number and 0.5 is not a whole number, therefore it is not a polynomial. I hope you understood. Let us go with example 4. To understand better, I will take another example. Okay. 10x cube minus 3x to the power minus 2 plus 21. So is this an algebraic expression? Yes, it is an algebraic expression because it's a term, therefore it's an algebraic expression. But is this a polynomial? No, it cannot be considered as a polynomial because the variable x has a negative number as its power. So minus 2 is not a whole number, therefore it is not a polynomial, but it is an algebraic expression. I hope you got the concept. So what is a polynomial? A polynomial is an algebraic expression. No doubt in that. A polynomial is an algebraic expression whose exponents are non-negative integral powers or whose exponents of the variables have non-negative integral powers are called as polynomials. Very important, I will repeat. What are polynomials? Polynomials are the algebraic expressions in which the exponential value or the power of the variables involved are non-negative integral powers. In the sense they should be always positive, in the sense they should be always whole numbers. So this is the type of polynomials. Okay, we will go with this. Okay. Numerical coefficient. So we will just revise this because it's very important. So I have an algebraic expression 3x square minus 4x minus 10. So there are three terms here. What is the numerical coefficient of x square? That it is minus 3. What is the numerical coefficient of x? That is minus 4. What is, okay, another one, 3 by 2 x square minus 2 by 3 y plus z. So what is the numerical coefficient of x square? Means it is 3 by 2. What is the numerical coefficient of y? Means it is minus 2 by 3. And what is the coefficient of z? Means it is plus 1. Minus x minus y plus z. So it's an algebraic expression. So what is the numerical coefficient of x? Means it is understood it is minus 1. What is the numerical coefficient of y? Is it is minus 1. It is understood there. And what is the numerical coefficient of z? Means it is plus 1. It is understood. So we need this understanding to learn better polynomials. So until now we have come across the basics required for learning polynomials. So you have learned what is a polynomial. So in next session I will be going with the standard form of a polynomial and the types of polynomials, which is very important. So this session is totally dedicated to the basics of your 8th standard and 9th standard classes. If you have not learned well or if you have missed the classes because due to some reasons, you can watch the video again and again to learn the concepts. So in the next video, I will be entering into the 10th standard polynomials. Right? So until then, stay home, stay safe, keep learning.